guess we'll just start. So I'm here to present MicroFlo, which is a flow-based programming for microcontrollers, including the Arduino, and especially the Arduino at this stage. Flow-based programming is a type of visual programming, so don't get scared just yet. I was kind of uncertain how to present this, because this is a very recent project of mine, started just 2 months ago. And so what I tried to do is go quite concrete on my motivations for this specific project, but it fits in interests of mine and thoughts and ideas that are a bit bigger, and I'll try to kind of leave with that at the end. So we'll go concrete on motivation and down into the code a bit, and a bit of a demo, see how it works, and then lift our eyes a bit and maybe think together a bit about what we can use it for, how it fits in. Maybe it fits in with someone else as well. So first, me and my perspectives on this. My name is Jon. I'm a software engineer professionally. I do Linux embedded type programming. I'm right now in the area of audio processing and a bit of graphics processing as well. I'm also a hobbyist. I play around with interactive installations. I work with some other artists. I try to help them with technical bits. I do like concepts with them and try to figure out, can we realize ideas, can we not? And I'm very active in the Oslo hackerspace called BitTrap, where I also help people with technical issues, artists, or people just want to hack something practical. I'm a consumer of electronics, specifically in this context. I use all kinds of things that have electronics inside that are more and more software defined. Everything from my computer to my phone to my stuff I have at home, my fridge and my TV and my everything, right? As everyone else almost on this planet, and as more and more people. So these are the three angles which I will try to cover as I describe the project. So it is a programming environment for Arduino, and this is where I started now. So Arduino is an excellent tool and project which has made programming microcontrollers accessible to many more people than before. It was made with this explicit goal in mind from professors at a university in Italy. And it's, for me, or the things I would like to highlight in how they became so successful are these things. It's programmable over USB. Before, you would typically need a hardware, you would always need a hardware programmer, which is an expensive device which is specific to a set of microcontrollers to just be able to program it. You can use it, you can use pre-programmed microcontrollers easily, but to program you need a special hardware. Now you plug in Arduino in your laptop, anything that has USB, you can program it. Brought a cross-platform IDE, which is of course free to use and free to download, no restrictions. There were other open source projects working on trying to make microcontrollers easier to use, but a lot of them were only for Linux. And as much as I'd love for Linux to be the relevant desktop platform, it is not. Windows and Mac OS X is much more relevant. And they have tons of excellent examples, and that is the key thing, enabler for people that are very new to microcontrollers. They just want to do something. They want to blink something. The Hello World example of Arduino. They want to have some bit of sound out. They want to react to a button press. They want to measure distance and do something with that. And Arduino has tons of examples how to do those individual tasks, and libraries that support this. And another excellent thing is Firmata, which is a generic firmware that you upload to your microcontroller. And now you can use your microcontroller as a I/O extender for your computer. So instead of programming a microcontroller, which still with Arduino is not a trivial task, you can use pure data instead, which I know a lot of people here do. You can plug it into Reactor, you can plug it into like any super collider, you can plug it into tons of things like that, which allows you to use your existing knowledge instead of having to learn specialized knowledge for the Arduino. And just the debuggability of a computer program today or something running on your actual device that you're also programming with is much better than if you have to run something on a separate device. So to me, these are the limitations, the things that, while Arduino is an excellent project and has taken us a long way in terms of making microcontroller programming much easier and more accessible, it still has its limitations. It is C++. They actually call it in the Arduino language, but it is C++ with a set of libraries, set of tools, and some simple pre-processing to make it simpler. But it is C++, and with that comes tons of complexity from inherent in the language. When you have some type mismatch, you try to use a int as a char or whatever, you can get precision issues, all these things that you have to at some point think about. If you just use an example, someone else has thought about it. And in terms of from a professional standpoint, I mean professional as in someone who would like to deliver products based on microcontrollers, it needs to work. It not only needs to work in the typical case, it needs to work in all cases. And that's where automated testing comes in, and where other like web-based environments or web-based programming and traditional systems programming are just way ahead of the Arduino. There's no one that even talks about automated testing in the Arduino environment, which is, I mean, for hobbyists, okay, it doesn't matter much. Although you do want your libraries that you use to actually work, which is a practical problem in Arduino. There's tons of times you find a library, yeah, it does exactly what I want, but it just doesn't work, right? So automated testing is a way to solve this, and there's tons of best practice not reached in the Arduino community. For hobbyists, more importantly, is the issue of composability, right? You have tons of examples to show you how to do this thing and that thing, but I want to do both. Or I want to do this and this, but with slight modifications. How do you do that? I mean, you have to then really grok, or you have to go to a deeper level understanding of the C++ code that you are using. You cannot simply copy and I mean, if I were a naive user, I would expect, okay, I have one program here, which does what I want in one way, and I want to use this other functionality. If I just put that on top of this or next to it or whatever, it should just work, right? If there's no dependencies or if they have nothing to do with each other. But that will not work in C++. Your declarations need to go on the top, and they need to interleave correctly. You need to have your setup interleave correctly, and you need to main stuff. And the things that go in the main loop, they cannot interrupt each other, or they cannot. It's important that the flow of one functionality does not impose on the other. And this is something that you, as the programmer, even if you're a hobbyist, have to think about, have to solve yourself. And it is LGPL. Again, from a professional standpoint, that is problematic in that you cannot use it for proprietary firmware, which is, again, one thing I would love for all firmware in the world, and all companies in the world, to deliver free and open source firmware for the devices, but it does not exist right now. And I think having a license which makes it impossible to do that just keeps that gap between open source and proprietary software existing. I prefer a liberal license where you can actually get those people that don't do open source firmware and bring them into closer to us, closer to the open source world. Even if they're not 100%, we can just try to reel them in at least. So that brings up MicroFlo, my project. So there's a flow-based programming runtime, and I'll show you soon what that implies exactly, but it's a visual runtime. It is a runtime, which means we do not generate code. We do not have this transformation between something you can see and manipulate, and then boom, you get code out. And if you want to go back, well, for you, as many other code generation tools and some visual tools do. It is plain C++ inside, which means that if you do know C++ and you do like C++, or if for some reason the visual environment limits you, you can extend it using the knowledge that you have from C++ Arduino code. It integrates with something called the NoFlow UI. So the NoFlow project, which is one of the motivations for me, is a JavaScript server-side client-side visual programming environment, and they're making a UI for this, and this is what I'm leveraging for UI. And if this project did not exist, my project would not exist either, because making a UI for a programming environment is shit tons of work, and they have gotten a Kickstarter with, to work on that full time, and I'm simply plugging into that. So let's look at the code, or let's look at how it works. So I'm just going to show briefly, like you have your Arduino plugged in, as you would in any other setup, and instead of like writing your code here, we provide a library, Arduino library, which is called MicroFlo. It's a standalone sketch. And this basically shows how MicroFlo actually works, although I won't go into details right now. Basically, it's just something you, like with Fermata, you say, okay, I want standalone Fermata. You just want standalone MicroFlo. It uploads to your Arduino in the usual way. You just press the button, and then you can go into the MicroFlo environment and program it that way. And that environment looks like this. So this is just a start page. This is very much work in progress, so don't be so critical about the details. Yeah. So let's look at the hello world of MicroFlo adapted from Arduino world. In Arduino world, this hello world is something that blinks an LED just once a second or whatever. And this is how it looks in MicroFlo. So, and this component actually is not necessary to use, just convenient, so I'll just remove it for the posterity. So, we have a timer component, which fires every 500 milliseconds, or whatever interval I put here. So, when that happens, this component will send a message out. This is very much like in Pure Data, LabVIEW, Reactor, all the other visual flow-based programming, or data flow programming. It sends a message out to toggle boolean, which will initially be have a 0 or a false value. And then when it gets a message, it will just flip to a positive value. It sends that out to digital write, which is modeled from the Arduino, which will write a boolean value to a certain pin. And I have to specify the pin, otherwise nothing exciting will happen. I have something on pin 11, yeah. So, yeah, this looks like it should work, except I need to enable the timer. This requirement will probably go in the future. I can now press play. And there was some activity on my little Arduino here, and you see the blue LED blinking at an interval of 500 milliseconds. So what we did now, we didn't actually upload new firmware per se. The firmware upload happens in the Arduino IDE, where all the components that are available, or at least the set that you specify, will be put in the microcontroller, and what we are uploading is a definition of our program. And that is basically it says, okay, we have create timer, an instance of a timer, create an instance of a boolean, create an instance of a digital write component, and then hook the output of timer into the input of this. So it basically describes just a graph. So and this is on a runtime. So that means that implies some certain things. For instance, you could do this over Bluetooth easily. You can reconfigure this with Bluetooth, or even some really low-fi 433 megahertz connection. So you could have Arduinos around, an interactive installation, and so on, where you know you have the functionality available, but you haven't decided, or you might want to reconsider later how exactly the program should look, and you could just reprogram it over the wire. And also they're much quicker. For instance, the nanos are pretty slow to upload. The flashing the firmware takes in the order of 15 seconds. This takes, and this is artificially limited right now, but it takes like 100 milliseconds. It could take even less if I just optimize it a bit. And this IDE already provides some advanced functionality. I'm not sure if I can demo it right now, but basically all the components are searchable as you would expect. This automatically saves when you make changes. So I made this change of removing this component. If I just go back, in there again. I'm at the exact same state I was. It uses HTML5 local storage. It has actually audio commands where like I can do, I won't do audio now, but I do add timer, I think. Command called add. I think I need to be exact about it. No? Okay, maybe it's a regression. I don't do the UI, so I can blame someone else for this. No, basically it's already command centric, and they're already thinking about touch interactions. How would this work on a smartphone? How would this work on a tablet? Because that's what they're motivated for. They want to explore programming paradigms that we can do with the new device paradigms that we are surrounded with, including touch, including of course servers and browser things. So this the same environment exactly, except for different components. You can use to program JavaScript, client side, server side. There's people working on Go and other Python as well. Hooks in the same way. So I'll go a tiny bit into the details now. Just if anyone is curious, you'll have your curiosity satisfied. So remember this strange looking stuff here. This is actually a serialization of a set of commands that describe how you build up a graph. And since I've been doing this a lot lately, I can read this by hand or like without looking it up. But basically, this is a reset. This is the MIME type. So it just says MicroFlo 02, which is like the version we're at. And then there comes a reset command. Basically means okay, scratch all of you have now. Add component, and these are like just specifies which component. Add component, connect edge, and then comes like these literals that you see, like for instance pin 11. I mean, we didn't. Interval is 500 here, and here comes the thing of composability. Right? This is the echo blink program of Arduino. Ideally, I would like to, and this will be possible in the future, just pull a box over this, encapsulate it into one new component, and then I would maybe bring out the interval, because it's interesting to change, and bring out the pin to a new component. Just imagine it being on the timer, for instance. And it's important to realize that this interval here is not limited to being a number or a literal. This is a port. So if I would want to change, like, oh, I want something that blinks, but I don't want something that blinks with a fixed rate. I want something that blinks depending on the distance of something. So what you would do, I have a pop meter, so you can use that as a simulator. So this ideally would be one nice block that I could just hook into, but analog reads, so I need to read a certain pin. I have it connected to analog 0. I need another timer, I guess. I need to trigger this. Yeah. Timer. Notice how I'm not changing that original piece of code in any obscure way as you would usually if you're required to. So let's read that every 10 milliseconds and true. So this could be a distance detector that you connect to the analog, or it could be infrared, light sensor, whatever. So instead of having this interval of 500, that's a bit static, right? I can connect the out component of this one. So now instead of 500, it is whatever the analog input will read, which will be, which it says in the documentation, will be between 0 and 1003. And the curious thing is, will it work? Oh, I have a poor connection. Bad breadboard. Do not like these Chinese breadboards. Come on. Oh, I cannot connect up meter correctly. Not. Well, anyhow, the point here is that things that in one program can consider to, or you can consider a program to be a library in the sense, or a component in the sense that it has some inputs that it might make sense to change, and you can change them statically, like changing the tools from 500 to 100 or whatever. But you can also hook up another separate piece of functionality to change that, to trigger that. So for instance, we could hook up to the enable port and turn that on and off depending on a button. And we would not change anything except for that input into the original program. And this is what I hope that will enable better composability. You don't have to change the existing program except for at the edges where you can plug in, and it's very visual. So what you can and cannot do is fairly obvious. Whereas in a textual language, you can do whatever you want. Just the compiler will bark at you at most things. So I think that's what I want. Let's just go in tiny bit to the store plus. So say that you don't have the components that you want, which will be the case right when it's new. Right now, all the components are in one file. Just bring that up. They're a bit bunched together. But the point here is that there is a single interface that you need to process. So here you can do whatever you want, and as long as you adhere to very simple rules, this will show up as a pluggable component in the UI. So here's the digital write component which we already used. So basically, it gets packets in on certain ports. I mean, it only had 2 ports. One was the input port, the other one was the pin port, and we have some defaults for it, doesn't really matter, but basically what we do is when we get some data on the import, we do digital write on the input-output layers that actually write something. And if you would look at the Arduino backend for digital write, well, it does exactly what it would do in the Arduino environment. It calls the digital write function. What is the point of this abstraction layer? Why don't you just call digital write directly? It is a runtime for microcontrollers, not specifically Arduino. And automated testing is important to us. So we can, this I/O component can be replaced by something that is for another type of device, say a ARM device or a microchip or whatever. And more importantly, we can write a test which uses this component, and I want us to be able to do this visually as well. And okay, I'm not sure how to explain this nicely, but basically we can feed it with packets in, and we can then look at what it does on the input-output component. So this has no side effects that we cannot observe. So we can fully manipulate this as a black box and observe its behavior from the outside and write tests that verify that it is correct according to what we want it to do. This is more for the professional programmer, but also for people writing libraries, so that the people using them can be secure in that, yeah, this stuff will actually work. Yeah. So that's what I want to say there, I think. Just a tiny bit before we move on about what I hope to do next. So next is subgraphs. I said that I would like to be able to just collect a set of components and make a new component out of that, and then have just some of the ports exposed. That is subgraphs. That is one of the next tasks. It really, right now, I'm already realizing with simple programs, I want to be able to do this. It's like making a function in a traditional programming language that is reusable. It really makes sense very quickly. It also reduces the visual clutter. You can visually communicate better what the program is supposed to do, and that you can separate, okay, this is input functionality. It might consist of very complex things or not like a bunch of stuff, but it's actually, logically, it's one unit. this is my my application logic. Might also be like 5 components. But logically, it's one thing. You want to be able to visualize that and also reuse that piece of functionality if you so choose. External libraries. So right now, all the components are in one big file. I want to be able to have external libraries as in Arduino and integrate with the npm package manager, which is used for Node.js, which is what we use here. So that you can just do npm install and then MicroFlo MIDI. So that so if someone else wrote a MIDI library, you can easily plug that in, and that should be able to contain both the components themselves and also like unit tests, so the tests that they have written, documentation, and so on. And right now you cannot, to be able to, if I write a program and I upload it from the UI, you can't, that is not stored automatically. But I want to just have a toggle button in the UI to say, okay, actually store this one so that when I unplug and plug it in again, it will still be there. So store it to the APROM. And then the AVR8 backend. So most of the Arduinos are AVRs. Right now I'm using the AVR library to do the input-output there and other convenience things, but I want to have something that does not use Arduino, so that I can fully say that this is MIT licensed and has no LGPL in it. That makes it edible for people wanting to use in proprietary software. So, and the vision, like long term. So, we want to have a full set of recomposable examples. So basically take all the Arduino examples, redo them in this visual environment, and make them into subgraphs that you can use, so that you have the same experience as with Arduino. You can start, okay, I start with the example, and I look, oh yeah, there's something what I want, and then you can bring in another example, plug them together, plug different things in, play around with it. That's something that the visual or something that's so quick, it takes a couple milliseconds to upload. You should be able to just play around and then press the button and see it, play on, and do it very quickly. But that's not quick enough. Right now you still need an Arduino. I want to have a simulator where you do not need Arduino available. And because we're using web technology to make all this stuff, or the people doing the UI mostly, I want that to be online. So people can go online, say, oh, this Arduino, this microcontroller stuff looks interesting, and maybe I can do something with that. They can have visual components that they can place out, also place out things like LEDs or motor sensors, and then work on that online, and without having to buy and wait 3 weeks for a Arduino to show up in the mail. And while they're doing that, if they think it's fun, they can order it and then they can play around. And when the Arduino comes, they have ready software that they can run. And then automated behavioral-driven tests. I'll just show briefly how behavioral-driven development is a style of test-driven development where you focus on what is the behavior of this component to the outside world supposed to be. Component can either be a library component, like in these cases, or it can be a whole program, a whole website, a whole service. But focus on what the user needs and wants from it. And they have like tons of nice tools. Here. So here I just have 2 tests right now. I'm very bad, sorry. And it gives a human readable output. And it's like, okay, if the documentation of the library is not so good, but it has decent testing, you can look at the test report and say, okay, yeah, it actually is supposed to do these things. So here we have like a description of some internals. So if you have a graph of forward components where you just have forward, and you send something in the end, so in the start, it should end up at the end. I mean, it's obvious functionality, but this can really describe a piece of software in a very thorough way, and be executed as an automatic test so you actually know that it's true. Yes, so I'm open for questions before I go up into the clouds and where this fits in to things. So would anyone consider doing this, using this type of environment instead of Arduino plus pure data, which I know people use today?
I can imagine, yeah. a lot of people will love that.
Yeah, I hope that. And Arduino plus Pure Data is a environment right now that will give you a similar experience, but it requires a computer to be present, either a laptop or a Raspberry Pi, something like that. And it's an excellent tool, and I know that a lot of people love it, but it will take 2.5 watts at least of power. It has a physical envelope that is fairly big, and it will cost you like starting at $35, whereas a single Arduino you can get for like around 10.
The program is at the end on the Arduino.
Yes.
The moment you modify it, it's completely that version on the Arduino.
Yeah, it is completely standalone on the Arduino. Yeah. Do we have any other questions? Comments? No? Okay. So why am I working on this? Why does this make sense? I mean, yes, people would like it, and I like it as a tool. It's a tool I want, but how does it fit in with bigger ideas? So one aspect of mine, which is important, thinking a lot about, is the concept of device freedom. So in free software, as defined by the Free Software Foundation, is a very well-defined concept. It is, but it's a concept that was defined when software ran on your PC, which is a box you had under the table, not even a laptop, but it was a big physical device which you would use sometimes during the day. Nowadays we have electronics everywhere around us, and they're increasingly software-defined. Like this, I'm sure. I mean, maybe these don't have a microcontroller in them, but there are plenty of DIY boxes that have microcontrollers in them. Your fridge has a microcontroller in. Your oven has a microcontroller. Your microwave oven, everything that has a display or does some amount of logic basically has microcontrollers in them. So this brings up the idea of electronics device freedom. If we have these things around us all the time, they're increasingly part of our life. The freedom aspect of software becomes important in those devices. We can't just confine this to the desktop anymore. We can't just confine this even to mobile. And some old and new problems come up. Free software as a political thing, I would say, has not succeeded. Open source is very, very successful. Open source is everywhere. But as mentioned earlier today, open source is frequently used against us. It's used to build proprietary services. It's used to build services which harvest data and provide data. So the freedom aspect of open source software, and free software specifically, has not succeeded. And I think one of the key things is that tools to make use of the freedom that you have with such code has not been provided with the software itself. You have this theoretical freedom that is there and that the code is available, but the code hasn't been even shipped to you most of the time. And certainly the tools which you need to manipulate that code and to use that code has not been shipped. And even if you go and get those tools, a compiler, some sort of text editor, and there's some build environment, all these things, the tools are very opaque. They're very difficult to handle. If we go for a more visual, direct, interactive experience, then I hope that is more likely that we can actually achieve some real freedom in software and thus electronic devices. So I imagine having a fridge, for instance. I already have a fridge with friends, using this, in fact, that actually comes with the IDE enabled. I mean, I'd love to have a tiny web server on it, connect with my mobile phone. Yeah, this is Jon's fridge, and I get that IDE that I showed you on my phone. It's standard web technology, and it probably, I mean, as a device, I most likely want to just maybe I don't want to do anything about it, but I might want to know, okay, has it been able to keep the temperature that it's supposed to keep? Has it been able to do that? What is the log of the temperature? Has it have there been any troubles there? Am I happy with the temperature thresholds that are there? Mine is set to 4 to 5 degrees. Maybe it's a bit high. Maybe I want it lower because that's better for your food. I mean, I should be able to just do that easily. But if I so wanted to, I should be able to go deeper. I should be able to go inside this box that is an entire fridge and say, oh yeah, here's the thermostat, here's the thermometer module. It reads out in this way. Here's the logic that defines when to turn the cooler on and off. Here's the things that make the light bulb go on. For instance, like right now, I have a fridge in my living room, kind of a studio, and sometimes people sleep over and they sleep fairly close to the fridge, and it's an old fridge. It's quite loud, so I would want to just be able to have like a night mode on it. Push a button, and then until some reasonable time in the morning, 11, it will be quiet, and not be so worried about maintaining the temperature, but be more quiet. That's something I would really like for my device. And so this explorability and this learnability and this being able to go deeper, deeper, deeper is something that I really want. But it brings up one very interesting new issue. Sorry. Which is that of safety. I mean, software that's running on your computer generally does not have the freedom or the power to destroy your computer or the things that are around the computer or kill the user of the computer. Whereas if you have a device, which is, I mean, maybe not as mundane as a fridge, but we could have mechanical machines. I mean, if you program that wrong, it might go horribly wrong. I mean, the thing could destroy itself, can destroy the other physical objects in the surroundings, can destroy the building. It can endanger people's lives. So how do we manage to give people the freedom to reprogram these devices in a safe manner, or in a manner that we can even ethically allow, right? So this is a whole new problem area, which I think is very, very interesting.
There's an interesting example about that, because there's a huge scene who modifies controller. It's a controller of cars, used cars.
Yes.
So it is used a lot. So.
Yeah, so mentioned here is that people already modified the controllers that are in cars.
Yeah.
Of course, your car has 30 microcontrollers already, and you modify them, yeah, your brake controller.
No, they do it to show that they don't have so many kilometers on it.
Yes.
That's how it is used. Yeah.
So another aspect is that of, I can't even pronounce the word, heterogeneous programming, where you have not only like one type of device, a microcontroller, that you can program, but you might have multiple microcontrollers that are different connecting to fulfill the same, a bigger system. For instance, in a factory floor where you have tons of machines that are monitored by different microcontroller circuits, the data is gathered to a bigger level in some sort of thing that collects statistics on it, this type of thing, and then there's probably a user interface for this functionality that the people in the control room sit and monitor the system with. Currently, you have to use a different paradigm for all those different classes of devices. Your microcontroller, you do C++ or something like that. If you have a server that's running data collection, yeah, maybe you'll use Python or something like that. On the on a web interface, which would be natural to do. Maybe you would even do a native client, and you have to do C# on Windows and Java on Android. Okay. Then these are all different things. But with flow-based programming being a fairly high-level concept, and I already show that I can program microcontrollers with this, and the guys that make the UI that I'm using are using it to program JavaScript, both on the browser and on the server. These are very different systems, different classes of devices. We can all program them using the same mentality. And I would want to be able to also look at the entire system as a set of boxes that fulfill some sort of logic, and be able to go into that. And we see that this kind of need is, this is the type of system that we call, things usually, where you even have servers connected to the internet, and there is a lot of data crawling again. So the same thing is in multimedia art, where you have some stuff doing sound, something doing visuals, something's doing interactivity, something's doing physical control, and they're all part of an installation, perhaps. It's infeasible. I mean, it requires a lot of technical skill for artists to to know all these different tools. If there was a more unified way, it's easier to think about on a high level, but you can also dig into the different ones more easily. I believe, I hope. Something I'm exploring. Yeah. Digital, just go quickly on this. Technology is ever more pervasive in our lives, and embedded devices, which classes devices that microcontrollers contain, are the devices that are most integrated into our lives. They will soon be in our bodies. They will be everywhere in our house, everyone in our office. And technology encodes and enforces a set of assumptions. And it might be on purpose, it might not just be because of artifact of the people that made it. And I believe that this creates a new type of power asymmetry, where the people that create digital tools, electronic technology, they are more and more defining the reality of many more people, as more and more people consume, use, and integrate with these technologies. And this power asymmetry is I think just going to increase if we don't have good tools that allow people to go from using to tweaking to hacking to professionally making. If that pipeline, that transition is not easy, then this power asymmetry will just grow. And I think that the people that are already, the groups of people that are already at risk, they will not be served well either in the future. Sad possibility of digital technology that I hope we can avoid. So this is one idea for maybe specific for PIKSEL. Can we do live programming without a PC? I mean, just with this and some input-output, with such a high-level model, so we don't have to do if statements and semicolons anymore. Could we exploit the fact that the code is spatial? I mean, that some functionality exists here, some is there, some is there. This is maybe enough that we can keep in our head, or maybe we can feel, touch, prod around this spatial area and find, oh yeah, there's the edge of that component, and maybe hover, and you get like, oh yeah, that's a timer. Then you get haptic and auditory feedback. Maybe that could be useful for live coding without the computer and without the general purpose interface that we have. Maybe we can do pen and paper programming where we say, okay, I want a component. I draw a square on the paper, cut it out, say, it should be a timer. If you have an optical system, another system that does that, and you can place them out on the board and reconnect them differently. Could be an idea for those into live programming. So, more info you find on these pages. Top is my project, and then there's the NoFlow UI and that bigger project on top there. So yeah, that's it. Thanks.